Let's now answer the last page where we have if sine of x equals 3 over 5 and my domain is between pi on 2 and 3 pi on 2, find cos of x and tan of x. I'm going to show you two ways of doing this. So let's start with option 1. Write out your Pythagorean identity. Sine squared of x plus cos squared of x is going to be equal to 1. Now I know that sine of x is equal to 3 over 5, so I can simply write that value in here. So it's going to be 3 over 5, and I'm going to square it. Then I've got cos squared of x equals 1. That is going to be 3 squared is 9, 5 squared is 25. So I could then continue to write out what I have. Next, I'm going to minus 9 over 25 onto both sides. So minus 9 over 25 to both sides. And so 1 minus 9 over 25. That's going to give me cos squared of x equals 16 minus 25. Now, I just want cos of x on its own. I want to get rid of this squared. So to do that, I'm going to square root both sides. So I'm going to get cos of x. Now, remember, when I square root a number, I'm going to get plus and minus as its outcomes. And the square root of 16 is 4. The square root of 25 is 5. But now I need to figure out whether or not it's going to be plus or minus. And to do that, I'm going to look at the domain that has been given to me. My domain is between pi on 2 and 3 pi on 2. So if we would just come and look at this unit circle here, I know that pi on 2 is here, and I know that 3 pi on 2 is here. So I'm looking at my second and third quadrants. Now, is cos going to be positive or negative in my second and third quadrants? It's going to be negative in my second and third quadrants. So that means it's just going to be negative. So now that I have that, I have one of my answers. One of my answers was asking for that. If we go up here, you can see that. So now I need to find tan of x. Now let's remember that we know that sine of x equals 3 over 5. So let me write that out. So we know this. We know that sine of x equals 3 over 5. So obviously all I need to do now to find what tan of x is realize that tan of x is simply the sine of x over cos of x. So that means I'm going to take my sine value, 3 over 5, and I'm going to divide it by negative 4 over 5. We can use our fancy stay, change, flip rule, which we learned all the way back in probably primary school. So you can see how maths just builds on top of each other. Just a never-ending story, mathematics. All right, now we're going to cancel that. We're going to cancel that. And we're going to end up with 3 over negative 4. And let me put that negative. We don't normally put it in the denominator. So that is going to be tan of x equals negative 3 over 4. So that's your tan value. So hopefully you got that. All right, so let's now answer this question, but through another way. So this is what we're going to call option 2. This is our second option. I did not show you this one in class, but it's a good way to do it. And now that we've got some extra time, we should go through it. So the way that this is going to work is we're going to just begin by drawing out a triangle, a right angle triangle, just like this. Perfect. Now, if we know that sine of x equals 3 over 5, sine of x equals 3 over 5, I could say, all right, sine of x equals 3 over 5. And there's something else we know about sine, and that is that sine is my opposite over adjacent. My opposite over, over my hypotenuse, sakatoa, my bad. My opposite over my hypotenuse, the opposite over the hypotenuse. So that means the 3 is going to equal to the O, and the 5 is going to be equal to the H. So when I come up here now, I could say my opposite, so let me label this as x. My opposite of that is going to be 3, and my hypotenuse is going to be 5. So that's how I'm going to do it. And now I need to figure out what this one here is going to be. Let me label that as b. So to find what my b is going to be, I'm going to go a squared plus b squared equals c squared, Pythagoras. Then from here I can go, all right, my a squared is going to just be 3 squared plus b squared equals c squared is going to be 5 squared. So that's going to be 9 plus b squared equals 25. then b squared is going to be equal to, I'm going to minus 9 from both sides, so that's going to be 16. And finally, to get rid of this b squared, I'm going to square root of both sides, so I'm going to get plus or minus 4. Now I need to figure out whether it's going to be plus or minus, and that's where we're going to have to look at our domain here. So here's my domain, and my domain is saying I'm between pi on 2 and 3 pi on 2. So I come up here, this is pi on 2, and this is 3 pi on 2. Now, if I am looking here, so I'm looking here, and I can see that my sine of x equals a positive number. So out of my second and third quadrants, which one is going to be a positive sine value? And obviously it's going to be this one, the one above the x-axis. So I'm looking up here. I'm looking up here. So if I was to draw this out, if I was to draw a right angle triangle here, it's going to look like that. It's going to look like, whoops, like that, and then like that. So as you can clearly see now, this is going to be positive, which we already knew, and this one is going to be negative. So if I was to write this in, I could say that this is going to be negative cos of x, and this one here is going to be sine of x. And hopefully you can see that this way of doing things is really utilizing similar triangles, things like that we've seen before, and we're getting to the same answer through that method. So really we've just drawn an alternative, a similar triangle to what we've seen here. This is of course a unit circle, so this line here would be 1, but we're just utilizing similar triangles, and if you can figure out whether this is positive or negative, that's really the hardest bit of option 2, and that's where everyone makes a mistake if they do use this option. Everyone makes this mistake because they don't label something as negative. So now that we've done that and we know that this is going to be a negative cos of x value, that means this is going to be negative 4 down here. This is going to be negative 4, which means that this here is going to be negative 4. So now that I've got this, I can figure out what things are. So this is the all-important thing that we have created. So actually what I'm going to do is I'm going to copy and paste it. Let me grab it. Let me grab this, because this is really important. Let me put this over here, and let's now figure out what our answers are going to be. And I've left out a thing there. So now I can figure out what cos of x is going to be, because I know that cos is adjacent over hypotenuse. And so I look here, my adjacent is going to be negative 4, and my hypotenuse is going to be 5. So that is going to be my answer. And that is what we saw over here. Then we can come down and we can figure out what tan of x is going to be. And I know that's going to be opposite over adjacent. So my opposite here is going to be 3, and my adjacent is going to be negative 4. So it's going to be negative 3 on 4. And that's what we found over here, negative 3 on 4. So which way do you like better? Do you like option 1 or option 2? It's really up to you. Yeah. Let's now go through the very last question, and let's utilize option 2 again, just to really show you how it works. So what we're going to do is we're going to read the question: if tan of x equals negative 1 over 3, and this is my domain, find sine of x and cos of x. So I'm going to begin, like I did in option 2, by drawing out a triangle, a right angle triangle like this. I know that I'm dealing with tan of x equals negative 1 over 3. Now, I know that tan is opposite over adjacent, So that means my opposite is 1 and my adjacent is 3. So I come over here, I'm going to label this as x. That's my angle. My opposite is going to be 1 and my adjacent will be 3. Now, I have a negative here. So one of these has to be negative. But which one is going to be negative? We're going to figure that out by looking at my domain, which is between pi and 2 pi. So I'm going to come here, this is pi, this is 2 pi. So I'm looking at either my third or my fourth quadrant. I know that tan is negative in my fourth quadrant, not my third quadrant. So I'm looking at my fourth quadrant. And if you wanted proof of that, or just a tactic that we've seen in class, sometimes we think of cast. So cast tells me that everything is positive. My tan is positive. My tan is positive in my third. So it's not going to be positive in my fourth. It's going to be negative there. And because this tan of x equals a negative number, this is what we care about, the fourth quadrant. So let me rub all that out. So I'm looking at this quadrant right here. So if I was to come now and draw in my cos of x, and then draw in my sine of x, what can you immediately tell me about my sine of x? It's going to be negative. It is going to be negative. So that means I'm going to come here and make this -1. So that's the hardest bit of doing these types of questions. If you can do that, you're golden. All right, so now we have to figure out what c is going to be. It's going to be a squared plus b squared equals c squared. A is going to be, well, whatever, -1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. 10 equals c squared. Then we're going to square root both sides. Square root of 10 equals c. We don't think of this as positive or negative because, you know, this is positive, this is negative, this is just like a length. So we're just going to say that this is the square root of 10. Perfect. Now again, we have created the all-important triangle that we are now going to use to get our answers. So let me grab this and put it over here. This is really important, what we've created here. And we can use this to solve for our answers now. So if you wanted to find what sine of x is going to be, what you're going to do is, well, that's opposite over hypotenuse. So here opposite is -1 over hypotenuse is square root of 10. So that's going to be your answer. Next, you're going to have cos of x, which is adjacent over hypotenuse. So we look over here, adjacent is going to be 3, hypotenuse again is going to be the square root of 10, and there is your answers. So that's how we answered them. So hopefully this was helpful in getting to your answers. And yeah, that covers using your Pythagorean identity for these questions. I hope this was helpful.